We were having a little discussion yesterday towards the end of the lecture about the use of Microsoft Excel for doing matrix multiplication and other matrix operations. So I wanted to record this tutorial to give you a sense of what I would expect on a homework problem if you were to use Excel for most of your work. So if you want to hand in an Excel spreadsheet, I think this is a pretty decent example of what would be an acceptable level of formatting and documentation. So I'm going to do this by way, so we're going to learn a couple of things. One about how to properly format your homework submission, but also about how to use matrix operations in Excel. Okay, so I'm going to demonstrate this with these examples from the end of section 7.2 in your textbook. Okay, so this example number 11 is about calculating the costs associated with production of a couple of models of computers. So I'll let you read this. You can pause the video and take the time to read this. But what I've done is I didn't want to retype all of this. So I used the snipping tool. I'm using Windows 11. I think the same thing applies in Windows 10. There's a shortcut key that's really useful, and that is the Shift key plus the Window key plus S puts you in snipping mode. I can now come along and drag a window around the part of the problem that I want to copy, and I can copy this, and then I go to my Excel spreadsheet, and I've already pasted into this spreadsheet, but if I wanted to paste again, I can just right click somewhere and click paste, and it puts a copy of that snipped picture into my document. All right, so I've done 3 of these examples, and I guess the first thing to point out is that you start out in a spreadsheet, in a workbook, with the single spreadsheet. I think it's called Sheet 1 to begin with. I renamed the sheet for the purposes of being able to identify which problem I'm solving, so I just called this one Computer Production. So the way to do that is you go down to the tab, you right-click on it, and you go to Rename, and that allows you to type some convenient name down here for you to remember. This might be, if you were working on your homework, it might be Homework 1, Problem 1, or something like that. Okay, so now I've got a nice statement of the problem that I'm trying to solve. Computer production, matrix times a matrix. And we can read through this. Essentially, it just says that there's a company that produces 2 models of computers. Each computer requires the use of raw components, labor, and other costs. And so this has been put in the form of a matrix for the 2 models of computers. So we have a PC 1086, a PC 1186. When I say this has been put in the form of a matrix, well, this was given in the problem statement for the example in the textbook. I didn't do anything to create these. I simply transcribed into my Excel spreadsheet. But of course, that has to be done with a little bit of care. So I typed the columns of the A matrix, and you'll notice over here I put a bolded A equals there to show that this is the A matrix that I'm dealing with. I put the column headers, which are the computer model numbers, and the row headers are simply here for my convenience to show me what each of these cells in this matrix mean. So for the PC 1086 model, the cost of raw components for the production of the PC 186 model is 1.2. I don't know what it says here in, I guess in, let's see, in multiples of 10, no, sorry, this is multiples of 10,000. I don't know what the costs here are. I guess it's in millions of dollars for a production run of this type of computer. Anyway, so there's 0.3 labor costs, there's 0.5 miscellaneous costs, and then this is the cost structure for the PC 1186. There's another matrix defined, which is a B matrix, which is the number of units produced per quarter. So we have 4 quarters in a year. Those are my row headers. These are the machine models. So to calculate the costs per quarter for raw components, labor, and miscellaneous, I need to take this A matrix multiplied by this B matrix, and that gives me this C matrix, or my output here. So I've clearly identified what's A and what's B and what's C. C is equal to A times B. And I've kept my row, or my column headers and my row headers here. to identify what the different cells mean. Okay, so let's first of all define the A matrix, and I'll show you what I did here. So the first thing to do is I just typed the column headers and the row headers, nothing mysterious there. Then I filled in the cells of this matrix, 1.2, 1.6, and so forth. Okay? Originally when I did this, the cells just had a white background, but I wanted to mark out the cells a little more clearly as to being a matrix. So I can't put the large square brackets that I would normally do on a piece of paper. Rather, inside Excel, what I'm going to use is the painting tool to paint the background a gray color. And that kind of helps guide my eye to show that this is the A matrix inside this gray area. Now, to get the columns to sort of self-size, if I want them to, say, shrink column E to fit what the contents of column E are, and the same for F and G, I simply go up to the top of where the column headers are, and I select each of those columns. So I simply clicked on E, and then I drug my mouse over to select columns E, F, G, and H. And then I find one of the lines here. I can drag this line out, but if I double click that line, it'll automatically resize these columns to fit the content of the things that are in the columns. So that's one bit of formatting that I did, in addition to the coloring of the background with this gray. You'll notice also when I select this 3x2 matrix, if I pay attention, there's a name defined for this matrix. I called it matrix A. The way I did that was to come in and manually select this range, right click on it, and go to define name. So I've already defined the name of this region as matrix A, so I'm not going to redefine it PC 1086. I'm just going to leave it defined as matrix A. So a similar thought process applies to matrix B. So matrix B is a 2x4 matrix. Again, I filled in the data, colored the background gray, and defined a name for this region to be matrix B. You might also notice that I have the word quarter up here that's spanning multiple cells. So I simply typed quarter in the cell M15, and then I selected it and dragged across these four columns and clicked on the merge and center button up here under the home menu on the home ribbon. I got the merge and center, and so that puts the header quarter to span all four of these rows, and it looks kind of nice. All right, so now you'll notice if I just click in any one of the cells of matrix A, it doesn't define that as matrix A. I have to select the whole thing for it to be matrix A. This is convenient because what I want to do next is take matrix A and multiply it by matrix B. Well, I've defined matrix A and matrix B with easily understood names, matrix A and matrix B. Now, I come over to this region where I want my C matrix to show up, and I type in the formula mmult, and then it asks me for two arrays, array 1 and array 2. Since I've already named my arrays conveniently matrix A and matrix B, I can simply type the name of those arrays there, and it shows up in my spreadsheet. I'm going to delete this area. So I clicked on the top left cell, the 1-1 cell, and hit the delete key, and that entire array goes away. So I'm going to reproduce it by going to this cell and typing in the cell formula mmult for matrix multiplication, and array 1 and array 2 are asked for. Now I defined a name, so I can simply type the name here, matrix A, and for matrix B, I could type matrix B, or if I hadn't defined a name for it, I can simply come in and select that range, and Excel recognizes that range is already being defined with a name called matrix B. So there we go. We've reproduced that data for the matrix multiplication. Now, had I done this by hand, or if I wanted to check my calculations, I would know that this first entry here, the 1-1 entry of C, is the product of row 1 of matrix A times column 1 of matrix B. So let's check the math here and make sure that we're doing this appropriate. So I'm going to just work on a space down here. I'm going to do row 1 of matrix A times column 1 of matrix B. So that's 1.2 times 3 plus 1.6 times 6. And that gives me the number 13.2. Well, that checks out with exactly what I got up here. If I wanted to check the second entry, C12, that would be, let's see, matrix A row 1 times matrix B column 2. So here I have 1.2 times 8 plus 1.6 times 2. And it checks out. I've got 12.8, just like I thought I should have here. Let's go over to, so that was cell 1, 2. Here's 1, 3, 1, 4, 2, 4, 3, 4. So if I type in this formula properly, entry C34, I should end up with the number of 6.3. So that would be row 3 times column 4. So row 3 in matrix A times column 4 in matrix B. So this is 0.5 times 9 plus 0.6 times 3. And that works out to be 6.3. So obviously I could type in a similar formula for every cell in matrix C just to test myself and make sure I understand what's going on with the matrix multiplication, and that in fact the matrix multiplication is being done properly, and it is. So I wouldn't necessarily expect you to type in these reality checks, but it's good practice at first to make sure that you trust the matrix multiplication operation of Excel. It's quite convenient and fast, but if I were to submit this as a homework problem, I would want to see something in a very nice systematic format like this, where the matrices A and B are clearly defined and the matrix C is clearly defined. I really prefer that when you create a matrix, you define a name for that matrix, like matrix B and matrix A. Okay, I'm going to stop this first part of the tutorial because it's getting a little bit long, and I'm going to discuss a couple of more things on these next two tabs.